Okay, so we will be discussing the June 2021 IAL M2 paper. Okay. Okay. So then we'll start with question number 1. Read question number 1, children. Question number 1, 5 marks. Okay, so 5 marks, 5 minutes. A motorcyclist and his motorcycle have a combined mass of 480 kilograms. The motorcyclist drives down a straight road that is inclined at an angle theta to the horizontal, where sine theta is 1 over 12. So immediately you need to kind of start imagining this in your head, children, and then draw the diagram, okay? So, and then when you see sine theta is 1 over 12, do you immediately take sine inverse and take theta? Is that how we do this? Do we immediately take sine inverse and find the theta value? Is that the way to do this, children?
No, we can get tan and cos too.
We can get tan and cos. I mean, basically, I think we will be needing cos. I mean, we'll see. Okay, so we will see whether we, I mean, probably we'll be needing cos, but I don't think we don't need tan, right? Because we will be taking the components, sine and cos, when we are taking those, resolving the weights. Okay, so we'll see. So let's draw the diagram. So the motorcyclist drives down a straight road that is inclined. So he's driving down a straight road that is inclined at an angle theta to the horizontal, where sine theta is 1 over 12, with the engine of the motorcycle working at 3.5 kilowatts. The motorcycle is moving at a constant speed of v. The resistance to the motion of the motorcycle is modeled as a constant force with magnitude 20 v newtons. Find the value of v. Okay, so you need to kind of draw the diagram here. So they say there is an inclined road. Okay, so you have an inclined road. So quickly let's draw the inclined road is there, and the angle is theta. So the angle to the horizontal is theta. So the now it's really important. You see this, the motorcyclist drives down. Do you see that, the word? So he drives down means what do you understand from there? He drives down means you need to make sure that he's coming down this road. Do you see? So it's important, not going up. So coming down. So those simple things are important. Okay, he drives down a straight road. So I'll just draw the motorcyclist, I just draw it like this. So this is the motorcyclist. So he's driving down. Okay, so tell me, what are the forces that we have here? So what are the forces I have over here? Obviously, you have his weight, right? The motorcyclist and his motorcycle have a combined mass of 480. Okay, so 480 kilogram. The weight is 480 g. Can I have the other forces acting over here? Okay, what else do we have? Talk with me. What other forces do we have? You can talk with me, children. Okay, unit says driving force. Yes, so driving force is correct. Yes, Trimesh, the R value you shouldn't mark just like that. I think you have marked it vertically, right? Do we mark the normal reaction vertically, or is there something more than that?
Perpendicular to the
Perpendicular to the surface. Okay, so that should be perpendicular to the surface, meaning should be like this. Can you see? It needs to be perpendicular to your surface, so it needs to be definitely in this manner. Okay, and then
resistance is there 20
and
V.
the resistance is there. Okay, so before that I'll mark the driving force. So they say the motorcycle is working at 3.5 kilowatts. This is the power. So anyway, when you deal with power, you have the driving force of the motorcycle. So the driving force of the motorcycle is pulling this down. Okay, so we'll mark that. So the driving force. So you have the driving force here, and also they say there's a resistance, right? So the resistance to the motion of the motorcycle is modeled with as a constant force with magnitude 20 V. So resistance is obviously to the other way. Now your motorcyclist is he's moving down this road. So he's moving down this road with a constant speed of V. So constant speed, okay? He's moving at a constant speed. So there is no acceleration. So if he's moving down, obviously resistance. The friction. So actually I marked here normal reaction as R. So resistance is to the other side, opposing the direction you are moving. How much is it? So 20 V. Resistance is 20 V. Okay. So I think I marked everything, right? And they have given us one more thing. The power is 3.5 kilowatts, children. So we don't work with kilowatts. So 3.5 into 1000, right? So 3.5 into 1000 watts, which means 3500 watts is what you have here. Your power is 3500 watts. Okay. So we are done. Now tell me, What do we do here? So when you see power, what's the equation that needs to come into your mind? Power equals, what's the equation that should come into your mind? Power equals, the power of the engine is equal to the formula, children. Power equals
Work done to the distance.
no, that is no, power equals, we say when it comes to the engine and the we say power equals driving force into velocity. Can you all remember this? Power equals the driving force of the engine into the velocity. Okay, so power is given here as 3,500. Power is 3,500. Driving force is unknown. No, yeah, we don't know it, right? It's not given here. Driving force we need to find, and velocity is given in V. I mean, your answer also comes in the term. I mean, you're supposed to find V actually. Okay, so the driving force is so velocity is V. Driving force is unknown. So let's get the value here. So D. So let me say D equals to 3,500 over V. Is that okay, children? D equals to 3,500 over V. Okay. Okay. Then what else can I do here? So you all know now this object is moving along this road at constant speed. So when it's moving at constant speed, children, you know there is no acceleration, which means the forces are balanced, isn't it? So then you guys know from M1 that when you have a system like this, when you have an object who is moving in an inclined plane, we use the x-axis as the axis parallel to the plane. Do you remember? X-axis is what we use as parallel to the plane, and y-axis is what we call as perpendicular to the plane. Are you guys okay with that? So we always, anyone who is, we try to make all our forces be parallel and perpendicular to the plane. So you can see R is perpendicular, 20V is parallel, D is parallel. However, your weight, the 480G is not in any of those directions. So 480G must be, what children? 480G must be?
For
Resolved.
80G
You have to resolve. Okay,
theta.
yeah, resolve. So then you get here what, Buddha? You get here
480G cos
cos theta, that is
480G sin theta.
and 480G sine, not sine theta, sorry.
Cos
theta. And then with our parallel to the plane, the weight component parallel to the plane.
sin theta.
480G sine theta. So that's it. Okay, so now what you can do is, children, the next step, the last step is, you can actually, now your object is moving at constant speed, right? So which means forces are what? When your object is moving with constant speed, there is zero acceleration. Your forces are actually balanced, isn't it? Forces are balanced, right? So if I take the balanced forces along the x-axis, so let me take downward as positive. So I'm going to take the x-axis. That means along the plane. So if I take along the plane, all the forces, the up and down forces, should definitely be balanced. Okay, so what do I have? Downwards. So all these forces must add up to 0. So downwards I have 480G sine theta. Do you agree?
Yeah.
Plus the driving force. So these two guys are acting down. So this is in balance with the resistive force 20V. So 20V is able to handle both of them. So these two guys are equal on either side. So therefore, there is no unbalanced force. The thing goes in, the thing goes with constant velocity because there is no unbalanced force. Can you all understand?
Yes.
So then let's put the values. 480 into G is 9.8.
9.8.
Sine theta is 1/12. I didn't have to even find cos theta. Did you see? I didn't bother to find. I was waiting if I needed cos theta, but I think I didn't need it. So we don't need to even draw triangles out here. Plus driving force we found 3,500 divided by V equals 20V. Children, can you all type this in the calc? 480 into 9.8 into 1/12. How much is that? How much is that?
392.
392. 392
Confirm 392.
plus 3,500 over V equals 20V. Okay. Now what's the next suggestion? What's the next best thing to do here? When you get like this, so you can see you have a V in your denominator. The best thing to do when you get such a situation is what? V is there in the denominator. We really don't want that. So I want to see all my unknowns in my numerator. So I'll multiply the whole equation with what?
V.
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 Exactly. So let's multiply. What do you get here then? 392V plus 3500 over V into V, that V cancels. And here you get 20V square. So it's actually end up going to give you a quadratic equation. Do you agree? It's
Yes.
going to end up giving you a quadratic equation. Take everything to one side. 0 equals 20V square minus 392V minus 3500. So children, you can type ABC in the cal. So you can type it. So this is M2. Just type ABC in the cal and tell me the V values. So let me bring it over here, the calculator. So mode equation, right? 3ax square bx plus a is 20, b is minus 392, c is minus 3500, right? So what do you get here? So you get some value like this, right? 49 plus 22 root 14 over 5 and 49 minus 22. Okay. So 49, okay, you guys got this right? Plus 22 root 14 over 5. I want you all to tell me the decimal figure here. What are the decimal figures, children? Can I have the decimal figure? This one is 26.26, which is 26.3. 26.3 meters per second. And I think the other guy is probably
Minus 6 points.
Minus 6 points. So that is not needed then. So you don't have to work. So we need to take the positive value of our velocity because we are moving down. We know the direction. Okay. So velocity should be, so you need to, when you get an answer like this, in this particular manner, it's you need to keep it to a to 3SF at least, right? So better to keep it like this. Okay. Is this clear? So this is the answer for question number 1.
Yes.
Okay, question number 2, a particle P of mass 1.5 kilogram moves under the action of a single force F Newton. At time t seconds, P has velocity V meters per second, where V equals 5t square minus t cube by plus 2t cube minus 8tj. So you can see you have your velocity in terms of I and j, right? And with respect to t. So find the force when t equals to 2. So children, you all know when you are trying to find the force, so the mass is given, you are moving under the action of a single force, the velocity is given. Obviously, when you're trying to find force, what's the first equation that comes into your head? If you're trying to find the force, the equation that comes into your head should be definitely what? F equals
Equal
F equal ma. F equal ma. So force, you have to find the force. So mass is given, 1.5 kilogram, mass is given. But what about the acceleration? F equal ma. I have the mass. How do I find the acceleration? They have given me the velocity. How do I get the acceleration from velocity?
differentiation, right?
Very good. You differentiate, right? So the velocity must be differentiated to get the acceleration. So you all know here velocity equal 5t square.
When you differentiate acceleration, you get speed?
No, when you integrate acceleration, you get the velocity. Okay. So you should remember the rule, the displacement differentiation, velocity differentiation, acceleration. The other way, acceleration integrate, velocity integrate, you get displacement. Is that okay, Buddha?
Yeah.
So the order you should be very clearly remembering. Okay. So velocity, so dv, we differentiate with respect to time. So we say dv by dt. Isn't it? dv by dt also you may remember in M3, right? dv by dt is what we call as acceleration, isn't it? dv by dt is acceleration. So when you differentiate here, what do you get? 5t square, you differentiate, you get 10t. T cube differentiation is 3t square. Do you agree? So this is the differentiation of the I component. 10t minus 3t square plus here you differentiate 60 square, right? 3 times 60 square minus 80 differentiation is minus 8j. Agreed? Agreed. So this is the dv by dt, or in other words, your acceleration. So this is the acceleration. So they are very clear about the acceleration they want. They want the acceleration at what time? They want the force when time equals 2. So put time equals 2 and get the acceleration, children. So put time equal to, so 10 into 2 minus 3 into 2 square I plus 6 into 2 square minus 8. I want the answers fast. Tell me how much is here. 10 into 2, 20 minus 3 into 4, 12. So 20 minus 12 is how much? That is 12y, right? 12y. Confirm. Check the answers. Confirm. 6 into 2 square. 6 into 4, 24. 24 minus 8. Here. Did I do a mistake here? 10 times 2, 20. 20
It
minus
should be 8, right?
8.
8
Sorry. I'm sorry. 8. I'm sorry. This is
and
8.
16, J.
And this is 24 minus 8 is how much? 16, right?
16. Yeah.
Yeah, sorry, 16J. So acceleration is 16. Sorry, 8I plus 16J. And now we are done with acceleration. So let's use now F equals MA. So you're supposed to find the force. Mass is 1.5 kilograms. Acceleration is 8I plus 16J. So multiply inside with 1.5, 3 over 2. 8 into 3 over 2. So how much do you get?
12.
Yeah, 12. 12y. 16 into 3 over 2. 16 into 1.5.
24.
24. So force equals 12y plus 24j. Is this the final answer? Can we leave it like this or do we need to go more? Do you need to find what we call as the magnitude? You don't really have to, children, because they say to find the force. Okay, so when they say, if they ask you to find the magnitude of the force, you need to go 12 square plus 24 square root. But when they ask you to just find the force, obviously leaving it in terms of I and j is totally fine. Okay, so this should be your final answer. Okay, I'll move on to the next part. At time 0,
Okay.
P is at the origin, no. So these are what we call as initial conditions. At time 0, P is at the origin. Or immediately, what do you need to understand from there? So at time 0, if your particle is at the origin, it means at time 0, the displacement, isn't it? The displacement is 0, isn't it? Time 0, displacement is 0. Do you agree?
Yes.
The displacement is 0. At time 0, your displacement is 0. Find the position vector. So find the position vector of P relative to O at the instant when P is moving in the direction of the vector J. Okay, so this has a little bit of M1 also. When P is moving in the direction of vector J. So do you remember when I told you when something is moving in the direction, what are they referring? When someone is moving in the direction of vector J, the direction, how do we work with this? So this is something you know in M1. We have worked with stuff like this in M1. What do you do here? Let's say P is moving in the direction of vector J. So direction of moving means it refers to which person, which quantity here? The acceleration or the velocity or the force or what is it? When you say direction, I have very clearly told you all. What is it? When they say direction, you must refer to which person? They say P is moving in the direction, or that is P is moving parallel to the vector J.
Velocity.
Okay, very good. Velocity. So your velocity is parallel to vector J. Your velocity is parallel to vector J. It's moving in that direction. Okay. So then I've told you how to deal with these sorts of things, right? Do you remember how to deal with this? Velocity is 5t cube minus 5t square minus t cube. I. And how do you deal with the parallel line? You remember me telling you how to deal with it? To make parallel equal, what else do you need to put here? You need to put a, when you make the parallel line equal, you need to put a, yes, Dalashika, very good. You have to put a constant. You have to put a constant. Can't you all remember? So these are M1. This is M1. You need to remember M1. Okay, so your velocity is what gives you an idea of your direction. So it's parallel, it's moving in the direction parallel to vector J. So velocity is parallel to vector J. Okay, and then what you can do here is you have to, obviously from that you have to find the time here, children. So here kj, that means 0y, isn't it? 0y plus kj. So when I'll compare the coefficient for I, isn't it? This is how we do, right? So in M1, this is even there in M1 vector. So compare coefficient for I. So I get here 5t square minus t cube equals on the other side, what's the I coefficient? This side is
0.
In this side, there's no I, means it's 0. Okay, so take, I think you can simplify this. We can factorize. I can take t square out and I get 5 minus t. So I get t square equals 0 or I get 5 minus t equals 0, which means t equals 0 or t equals 5. Can you see? So there are two times. There are two places where it's going parallel to this vector j. One at time 0, the other one at time 5. Okay. So then we obviously we don't need to work at time 0. At time 0, it's at the origin, and we don't need that one. So we will be needing the time 5. So at time 5. So that's what we need here. Okay. So there's no need to mention time 0. It's not okay. So find the position vector. So we need to find the position vector, children, of P relative to O at the instant when P is moving. At the instant when P is moving parallel to vector J means at the instant when time equals 5 seconds. There now you don't need to read this part. You don't need to read this part. Your task is to find the position vector of P at the instant when time is 5 seconds. Okay, did you understand the question? Your task is to find the position vector when time is 5 seconds. So how do we do it? How do we get the position vector? They have the velocity here, Buddha. From velocity, how do we go for position vectors? From velocity, how do we go for position vectors, Putala? I think you can see your velocity is in terms of I and j. So I think just a moment ago, you were asking me what happens when you differentiate velocity, what happens when you integrate velocity. So obviously velocity here, your velocity is with ij, Buddha. So when you integrate velocity, what will you get?
Displacement.
Displacement. However, you need to realize here that you are getting your this in terms of I and j. Can you see? You get this in terms of I and j. So actually, when you differentiate something like this, you are immediately going to get what we call as position vector. Position vector means it's the xy coordinate. Do you know the position vector means it's the x coordinate and the y coordinate of your position where you are, your x coordinate and your y coordinate. So in your M2 book, you can refer this if you can't remember. So when you have your velocity with I and j, when you integrate it, you end up getting what we call as the position vector. So that means you the I gives you the x coordinate of your position and the j gives you the y coordinate of your position. Okay. So the velocity here is 1. So your velocity here is 5t square minus t cube I plus 2t cube minus 8tj. So let's integrate and get the position vector. Okay, so when you integrate, what do you get here, children? So actually, you want to you can actually now until you have to do this until time equals 5, right? So at the end, you need to find the position vector when time is 5. You can directly do the integration also. So when you integrate velocity, let's integrate the velocity. So what do you get here when you integrate? Tell me. 5t square, integrate 5t square, what do you get? 5t square when you integrate
5t cube over 3.
5t cube over 3 minus t cube integration is t to the power 4 over 4.
4 divided by 4.
And then remember to put the I. So remember we are working with position vector. Now velocity integrates gives you the position vector. Okay, and here 2t cube, when you integrate, you get 2 t to the power 4 over 4, adding 1 to the power and dividing. 8t, when you integrate, you get 8t square over 2.
T square divided by 2.
So j, and then when you integrate, if you integrate without limits, you have to put the plus c. You have to put the plus c. Okay. So then, children, here you get the position vector r, or we say r here, the position vector 5t cube over 3 minus t to the power 4 over 4i plus here you get t to the power 4 over 2. My simplification is clear, right? Minus 4t square into j plus c. How do we find the plus c? So they have given you some limits here, isn't it? They have told at time 0, it's at the origin. At time 0, it's at the origin means what, children? At time 0, origin means what's the coordinate of the origin?
0, 0.
0, 0.
0i plus 0j. So R represents, remember, R is the position vector. So R represents the position vector at any given time. So here at time 0, you are at the origin means you are at 0i, 0j. So put it here. So R is 0i, 0j. Because I'm putting 0i, 0j because our equation is in terms of I and j. So you better use that. So here when time is 0, I think you can see here 0, 0, right? So the whole thing sums up to 0. Here also 0, 0. Whole thing sums up to 0. Plus C. So what do you think will happen to C? Does C have any ij value?
C is 0.
C is 0. I mean, if you had here even a 1i, I mean, if this was at least even 1i, C would be minus 1i if it had a value. So here C becomes 0, which means your R is simply going to be, your position vector is 5t cube over 3 minus t to the power 4 over 4i plus t to the power 4 over 2 minus 4t square j. So they have told you very clearly find the position vector when it is what? Moving parallel. Just remove it when time is 5. Because I found when it's moving parallel, time equals 5. So you have to find the position vector when time equals 5. So just go and replace what? And replace what? The time with? Replace your time with 5. So tell me the answer. Tell me the answer. What do you get here? Does our C depend on what is that? The I? What is I? C depends on it. I mean, when you integrate, your C also sometimes, I mean, you can check in your book also what we've done. Your C can come in terms of I and J. Your C may come in terms of I. In this situation, everything is 0. So C becomes 0. But I mean, in situations where you have figures here, your C may come in terms of I and J. Okay, your C may come in terms of I and J. Can I have the answer? So what's the answer here? I want it quickly. 5 into 5 to the power 3 over 3 minus 5 to the power 4. So how much is that?
625 over 12.
625 over 12 I plus the other guy. 5 to the power 4 over 2 minus 5 into 4 square. 5 to the power 4.
425 over 2.
425 over 2 j. So yes, so this is the position vector when the particle is moving parallel to vector j. Okay. Okay, question number 3. The uniform lamina ABCD is a square of side 6A. The template T shown shaded in figure 1 is formed by removing the right angle triangle EFG and the circle center H and radius A from the square lamina. Okay. So the triangle EFG has EF and EG both 4A with EF parallel to AB and EG parallel to AD. Okay, you guys are following this, right? The distance between AB, okay, the distance between AB and EF is 1A. Okay, and the distance between AD and EG is 1A. So everything is marked on the diagram. All the things they mention here are marked on the diagram. Okay, that's fine. Then the point H lies on AC on the diagram. Can you see? Point H lies on AC. Point H lies on AC. The image gets distorted there. Okay. The point H lies on AC, which means it's lying on our diagonal. And the distance of H from BC and the distance of H from BC is 2A. I think that they have not marked. Shall we mark that? The distance of H from BC is 2A. So mark that, children. Because the thing is, they have not marked that. So you will definitely need that. So the distance, so that means the perpendicular distance of H from BC is 2A. Agreed? So that we need to mark. Okay. Show that the center of mass of P is a distance of this much from AD. Okay, from AD. So from AD means they want us to find the. So if you are trying to find now this combined system has center of mass somewhere in G. So they want the distance from AG means they want you to find the X bar. They want you to find the X bar. Okay, so anyway, I think it's better that we have an idea of both X bar and our Y bar because I think we may need it for part B also, right? So anyway, what I'll do here is I will take D as the 0, 0 position. So D will be the center 0, 0. So what you need to do is think here is there are 3 objects here. Can you guys see? There are 3 objects. There is a square lamina, there is a triangular lamina, and there is a circle lamina. I mean, in the sense, lamina in the sense, so these 2 guys are removed. So what we need to do is we need to find the center of mass of each of these 3 objects, and we need to kind of, make our table. Do you remember? So we used to make a small kind of table and do so object, the mass, and the center of mass. Shall we work with this? So the first object is the square lamina. Square lamina, which is 6A by 6A. So how do you consider the mass, children? Do you remember in these kinds of 2D objects, when they don't give you a weight, what do we take as the weight? The mass. When they don't give you a mass, I've told you what you should use for the mass. What should we use? When the mass is not given in a lamina.
Area, right?
The area. Very good. Can you remember, children? So when you don't have a mass, if they give you a mass, you must use it, children. Remember, if they give you a mass, you have to use. Then don't use area. But if they give you if they don't give you a mass, you have to go with area, because we say the area per square for every square centimeter or for every square unit is equal. The area for every square centimeter for every square unit of this object is the same. It's uniform. It's a uniform object. Okay, so every square unit has the same mass. So when they don't give you a mass, you must go with the area. So what's the area here? 6a into 6a. The answer is 36a square. Great. 36a square. Okay, so what's the center of mass? Tell me the x bar and the y bar. So in a square, center of mass is exactly in the middle. Put tell me the middle coordinate here. What's the middle coordinate?
3a, 3a.
3a, right? X bar, y bar, so 3a, 3a. Everyone agrees with that? Any disagreement? Anything to comment about? Please talk. You need to talk as much as possible and get all the doubts cleared. The next one I'll take is the right angle triangle. So next one I'll take is the right angle triangle. So they have carefully given us all these values here. So they have given us carefully all these distances here, so that you can actually get the coordinates, because in a triangle you need the 3 coordinates, right? You add the 3 coordinates and divide by 3, isn't it? Okay, so can you tell me? I think you can easily tell me this coordinate, because this is like they've told you, this is a units away, this is a units away. Okay, so how much is the x coordinate of G? So this is a units away, right? So G, the x coordinate is a, right here.
And y also a.
Y is also, did you check the distance? So this is 6a.
They are given it's a.
This is 4a, right? So 4a plus a, this is 5a. Can you see, children? 4a plus this a, 5a is covered here. So that means to become 6a, there's another one more a here. Do you agree?
Yeah.
Can you see? So this is a plus this is 4a plus a, altogether 6a. So a comma a is the coordinate of G. A comma a is the coordinate of G. What about the coordinate of E, children? Get me the E coordinate. X coordinate is a. What about the Y coordinate? What's the height here? How much?
5a.
5a. Can everyone see that? Can everyone see that? A comma 5a. X coordinate is a, Y coordinate is 5a. Okay, now the next tricky one, F. What about the coordinate of F, children? X coordinate and Y coordinate. So think about it. You need to tell me the X coordinate here. So this
5a,
is 4a,
right?
Yeah, so this is 4a. Can you see, children? With the distance of 4a and here the a. So a and 4a all together, this is 5a. Can you guys see it? Again, this should go from the touching the this thing of the circle. So this is 5a. So x coordinate is 5a. But then what about the y coordinate? Y coordinate
That
is
is also
same as, same
5a.
as E, 5a. Same as E. Y coordinate of F and E are the same. I hope everyone is okay with this. If you have any doubts, please talk. Okay, so I have the coordinates now. Okay, let's get the area. Half into base into height. So what's the area? Half into base is, you can see right angle triangle. Base and height are just adjacent to the right angle, right? Half into 4a into 4a. Can I have the answer?
8a square.
8a square. Area is 8a square. And what about the center of mass? Add and divide by 3. Add the 3 coordinates. A plus 5a plus 0. Add and divide by 3. You have to add the 3 coordinates and divide by 3. What's the x coordinate? A plus 5a plus 0. That is 6a. 6a divided by 3 is?
It's 7a, right, teacher? Because
sorry,
G is a.
Sorry, G is a. I'm sorry. Yeah. A plus 5a plus a. Yeah.
7a divided by
7a
3.
divided by 3. And what about the other guy?
That is 11a divided by 3.
11a divided by 3.
Yeah. 10 plus
and y
a.
board. Okay. Correct name the A, 5a, 6a, 7a. This is 10a, 11a. Okay. So that is the triangle. It's the center of mass of the triangle. Okay. Next thing is the circle. So circle, children, what's the mass? Obviously, the area is pi r square. So r is radius is a here. Radius is pi a square. So pi a square. Is that okay? Center of mass, students. So you guys know very well. Center of mass of the circle is exactly in the middle of the circle. So how much is it? So what's the x coordinate here? Maybe 2a now. What's this distance? If this
4a.
It should be 4a. Can everyone see that? If this is 2a, this should be 4a. It makes sense that this should be 4a, right? If the other guy is 2a, so this is 4a. And what about the y coordinate with the radius is a. Radius is a, this distance is a. Isn't it? And then this distance is a, and also this other distance is also a. Have they given us any mention about that? They have not mentioned anything about the other distance neither. So actually we don't know about that. Okay, so we don't need to worry about that because we don't know about this. We really have not been told whether this is a or 2a, so let's not bother into going there. Okay, anyway, we don't need the y bar here, so we don't know that, so we'll leave it. Okay, anyway, so to find the final answer, because they're asking you to find the center of mass distance from AD. So that means you need to find the x bar. All the x coordinates are what we need here. So I just found the y coordinates in an event we need at the later stage. So anyway, at the end, what do you do? From your square lamina, the triangle and the circle lamina are what, children? They are
Removed.
So if they are removed,
Minus.
So minus. Can you subtract the areas from the square area? Subtract these two guys. So 36 a square. 36 a square. You have to subtract 8a square minus pi a square. Can you simplify and give this to me? How much is it? 36 minus 8 is? It's on the diagonal. Yes, unit. Good. So we can use that. This is on the diagonal. So I think
28a square.
28a square minus pi a square, and the final x. So this is x bar and y bar. So anyway, I need to only find x bar because I need to get the distance from AD. Okay, so let's take moments and we should be able to get the answer. So remember what you need to add and what you need to subtract. Remember these two guys are removed. So if these two guys are removed, those two moments should be subtracted. So what do you do here? You multiply the mass with the center of mass. This is like considering taking moments. So mass 36a square multiply with the x bar, with the x value 3a. 36a square into 3a. Then the next guy, children, we are not adding because we know the triangle is removed. We take minus 8a square into 7a over 3. Is that okay? Is that okay? And the circle?
Yeah.
Minus pi a square into 4a. Because why? We are removing the circle. So then this equals to, finally you have the final mass is 25a square minus pi a square into x bar. So which is exactly what we are finding. And when we simplify this, we should get the show that. So when we simplify this, we should get the show that. So I think you can see here 36 into 3, we get how much? 108.
We can cut a a throughout, right?
You can?
Cancel a a.
Yeah, not a, actually a square. So let me take a square. A square you can remove from everyone.
Yeah,
A square. From everyone you can remove a square. So 108a minus, can you multiply this? Can you multiply this? 8 into 7. So that is going to give you how much? 50.
6 over 3.
56 over 3a minus 4 pi a was 28 minus pi into x bar. So this, we should simplify this a little bit. So 108a minus 56 over 3a. How much is that? 108 minus 56 over 3 is 108 minus 56 over 3 is how much? 200.
268 over 3.
268 a over 3 minus 4 pi a over 3. No, sorry, just 4 pi a. So I think before I bring this guy down as a division, it's better that I take this, LCM with 3. Then I get here 268a minus 12 pi a. Whole thing divided by 3. Okay. And then we can bring this guy down. 268A minus 12 pi A over 3 times 28 minus pi equal x bar. Is this to show that, or have they taken the common thing out? Have they taken the common thing? They've taken the common thing out, right? Look at the show that, yeah, 4 times. So I think that then there should be a 4 in, that we can take out. Is it possible to take out a 4? So what do you get when you take 4 out? 268 divided by 4 is
67.
67A, and 4 times 3, right? So 3 pi A. Have they taken A out as well? Equal x bar. The A is outside, yeah. So we can take the A out as well, because A is also common. So 67 minus 3 pi, and A is, they've written it outside here. Okay, children, so this is the show that, the part A answer. Okay, so moving on to the next part. The template T is suspended from the ceiling by 2 light inextensible vertical strings. One string is attached to T at A. Okay, one string is attached to T at A, and the other string is attached to T at B, so that T hangs in equilibrium with AB horizontal. Okay, so now what they're doing is, they are now your center of mass is somewhere, I don't know, it might be, let's say it's somewhere over here. So it's not exactly in the middle, it might be somewhere. Okay, so this is the center of mass, but what you're doing is, you are going to hang this now from 2 strings. So one string at A, the other string at B, you're hanging this. The template is suspended by one string is attached to T at A, to the template at A, and the other string is attached to the template at B, so that the template hangs in equilibrium with AB horizontal. That means you keep it like this. It doesn't become, it doesn't get slanted. The weight of T is W. So you know where the weight acts. Weight acts at the center of mass. Okay, so the place where the weight acts is on its center of mass. The weight acts, the weight of the template is W. The tension in the string attached to the template at B. The tension in the string attached to the template at B. So this string, the tension here is KW. So this tension is KW, where K is a constant. Find the value of K, giving your answer 2 dB. So can you see several things here, children? So there are 2 strings here. Okay, the weight is there. They have given you the tension, kind of given you the tension in string B, but there is a string at also at A. Have they given you the tension or any indication about the tension in at the string A? Have they mentioned anything about string A? Given you a value for the tension of string A? Talk with me. No. Okay, no. But that doesn't mean there is no tension there. We have a tension there, isn't it? We do have a tension there, right? Are you guys with me?
Yeah.
With the tension at B, we have some kind of a tension A. Okay, so they are not equal. Tension A and tension B are not equal, but there is a tension, but they have not given that. So our task here is to find the value of K. Our task is to find the value of K. So what in this kind of a situation, children, what do you think is the best thing to do? Can you imagine? Now this is actually 3 marks, and it's quite easy if you try to remove all the other measures out of this. If you remove everything else here and try to look at this force, and this force. If you look at this on the perspective of only looking at forces, something should come into your mind. What is that?
Should be equal to the total weight.
Yeah, I mean,
Yeah,
you can
right.
see up equal down, the weights are equal, tension A and KW. These 2 guys are equal, that is correct. But I think that doesn't help me to find K. There is something very specific that you should do here to get the K value. Something that you do in M1 for system in equilibrium. What do we do? There's something else that we do.
System in equilibrium.
It's in equilibrium. See, it's in equilibrium. With this thing horizontal, with AB horizontal, it's in equilibrium. Let's say it here. See?
So
And it's in equilibrium.
wait, I'm not sure. In
M1, what's the thing we do in M1? You do up equal down. Can you remember? You make Y forces equal to 0. In addition, there's something. Yes, very good, you. So I have one answer. Very good. So that is actually correct. In M1, we also do another thing called what? We consider moments. Can you remember moments? So moments are really important. So if you take moments, around a certain point, and if there is a force on that point, you know, that person doesn't give the moment. So in here, the best place to take moments would be at A. Why? If you take moments at A, then we really don't need
Cancels
tension
out.
at A. So the tension
Yeah.
at A is not even, we don't even need it. So it's really advantageous if you take moments around A. So Himagattana, I think you can see we know all the distances also, right? So if I take this particle, the center of mass, and if I consider the distance, I think the x distance also we found it. We just now found it also. So it's quite easy, children. This is real. I mean, it's quite easy to be honest. Okay, but the thing is, there are only two forces. Moments, just two forces are there. So it's easy, but with all the mess, it might, you know, it might not be obvious. So moments around A, I'll take clockwise is positive anyway. We know anti-clockwise moment equal clockwise because it's in equilibrium. So sum of moments must be equal to 0. We start with W. So what sort of a moment does W give?
Clockwise.
Clockwise. Can you guys see? So around A, you guys can see W is pulling down. Around A, W pulls down, which means clockwise. So positive. Force is W into what's the distance, children? What's the perpendicular distance between this line of action and A?
X bar.
X bar, the one value that you found now. Because you found the distance from AD to this G. The X bar value is what you found, right? The X bar value is what you found in part A. Do you get me? You found the distance, the center of mass from AD, from the AD line. The X bar is what you found, children. Okay, then the other guy, the other force, there's only one more force, only KW. So KW, as you can see, it's going like
Anti-clockwise.
Yeah, it's anti-clockwise. So you can see it's pulling upwards. You take it from A it's pulling up. It's pulling up. So anti-clockwise. So you can put minus or you can say equal because it's going to the other side. Equal KW into what's the distance? Distance
6A.
is 6A. So that's it, children. Put the value. So W can be cancelled out. X bar value we found 4 times 67 minus 3 pi over 3 times 28 minus 5, and there's A out here, K times 6A. A to A will also cancel. The 6 goes down and get K, children. They want it to 2 dB. Get the K value, type everything in the cal. And the 6 comes down. You see, the 6 comes down. This 6 multiplication just came down over here. Type the whole thing in the cal. Get the answer of K to 2 dB. That's all. How much is it? It's a matter of typing on the cal.
0.51.
0.51.
Yeah.
Minus 0.514. So they want 2 dP. So 4 is lower than 5. So 0.51. 32 dP. So K value is 0.51. Okay, so we'll move to question number 4. A particle P of mass 0.3 kilogram is moving with speed 5 meters per second along a straight line on a smooth horizontal plane. The particle receives a horizontal impulse of magnitude J Newton seconds. Can you see? This particle is moving along this path and then suddenly it receives an impulse. You know, impulse is that sudden instantaneous force. So you receive the impulse and what happens? Immediately it will change the direction of motion of your particle. So what happens? The speed of P immediately after receiving the impulse is 8. Can you see the diagram? This particle was traveling along this path. It got the impulse. Now it's moving in this slanted path. Okay. The angle between the direction of motion of P, the particle, and before it receives the impulse, that is this guy, and the direction of the impulse. So the angle before deflecting and between the impulse is 60, as shown in figure. Find the value of J. They are asking you to find the value of J. So obviously here you have the impulse momentum, the rule, right? Impulse. So impulse I equal mv minus mu. However, now you can see here, the thing is I equal mv minus mu in M1 is very easy to use. Why? Everyone is in one direction. You have everything in horizontal or vertical directions. Now in here, you can see it's all over the place. Okay, so the starting one is vertical. This guy is, these are all acting at different angles. So in M2, if you remember, when we use I equal MV minus MU, do you remember we work with I and J? Okay, so it's better if you had this with I and J, so it's quite easy to use it there. So if you get your impulse in terms of I and J, if you can get your before and after velocities also in terms of I and J, things can be really easy, children. So what I suggest you to do here is, okay, let's get the initial velocity. What's the initial velocity? It's moving 5 meters per second. It's moving up, right? So if it's moving up, what do you call it? Going directly up means what? You know, this is the J.
5J.
5J, right? So going directly up, so you can say it's 5J. So U velocity is 5J. Okay, and then 0y 5J. You can say it like this. This is 0y 5J because there is no movement for X. There is no movement for X. Okay, then the next guy, final, let's take the impulse. Children, can tell me the impulse. So let's resolve it. So impulse horizontal component is what, children? Horizontal.
It's J. Yeah.
Yeah, J sine 60, right?
J sine 60
And vertical component?
J cos 60.
J cos 60. So if I write the impulse, then the impulse is what? First I, starting with I, so it's going to be minus J sine 60, right? Minus J sine 60. Why do I say minus? Because it's going to the other side, behind. You know, positive Y is when you go to the right. So if you are going behind, it's negative Y, right? Are you guys getting what I'm saying? Minus J sine 60 and J cos 60 is positive or negative? Going up means, going up means positive, right? Are you guys
Positive.
with me?
Yeah.
Okay, capital J cos 60 into J. So this is how you can break it. So I just broke it down. So this force, which is moving with the 60 degree Newton, you can break it in terms of I and J. Okay. And then the 8 meters per second. I think you can see we really don't have an angle here to break it, right? Have they given you an angle? They haven't. So we'll put an angle here. You put an angle. So now break this. How does it come? You get here 8 cos theta. And upwards you get 8 sine theta. So how do you break the final velocity? Tell me. Can you tell me? So what's the I component? It's gonna be, talk with me.
8 cos
8 cos theta I, but is it positive or negative?
it's negative because
It's negative. You are going behind. Can
left.
you see? You are going to the other side. If you are going to the behind of, if you are going to the other left side, it should be negative. And the 8 sine theta plus 8 sine theta, it's plus, right? Because it's going up, plus 8 sine theta into J.
Yeah.
Children, if you resolve this, if you take Pythagoras theorem for this and take the magnitude, you should get this answer. For all these guys, if you take the Pythagoras theorem, okay, you will be able to get the magnitude of this, the resultant again. So this is like they have given us a resultant. I am taking the components. So if you take the components and square it and root it, you will get these answers back. Okay. So now I will be using I equals MV minus MU, and now I don't need to worry about the directions. Why? Because all the plus minus have been considered. I really don't need to worry. So let's put, so I impulse, I get here minus J sine 60 I over J cos 60. You can use it like this. Do you remember? Mass is 0.3 times velocity. Final velocity is minus 8 cos theta, 8 sine theta. Do you get what I'm doing here? Minus mass is, your U is 0y and 5J. Look at this, children. Does this make sense to you? Yes or no? Children, what do you think about this?
Can understand it.
I and J I wrote up and down. And now what you do is you take each line separately. Take the I line separately. Take the J line separately. So what do you get here? Minus J sine 60. 0.3 into 8 is how much, Buddha? Minus 2.4, right? The minus mark will cancel out. Can you guys tell me the value of sine 60? Sine 60 is how much, children? Root 3 over 2, right? You guys need to talk with me. Children, move the 2.4 to the other side, make cos theta the subject here. Root 3 over 2 divided by 2.4. How much is it? So here you have root 3 over 2 multiplied by 2.4. Can you see?
Yeah.
The 2.4 goes down, so you get 5 root 3 over 24. Can you guys see the cal here? The way I typed, the 2.4
Yeah.
comes to the denominator. Can you see? Root 3 over, how much was it? 5 root 3, sorry. 5 root 3 over 24. And don't forget the j. And don't forget the j. Now what do? The next thing you do is, now you need to find the value of j. Your task is to find the value of j. Remember that. The next thing you do is I take the x components. What is it? So that gives me j cos 60 equals 0.3 into 8 sine theta minus 0.3 into 5. Are you guys okay with what I'm doing?
Yes.
So j cos 60 is half. 0.3 into 8 is 2.4 sine theta minus 0.3 into 5 is how much? 1.5?
Yeah.
Yeah. So I'm going to now what? I think you can guess what I'm going to do. I'm going to make sine theta the subject. I'm going to make sine theta the subject. So I get here half j plus 1.5.
Right.
Do you agree?
Yeah.
2.4 sine theta. Let's take the 2.4 down. Half j divided by 2.4 plus 1.5 divided by 2. I separated it out. Type both of them in the cal. Half divided by 2.4. How much is it?
5 over 24.
5 over 24 j. 1.5 over 2.4.
5 over 8.
5 over 8. So that's sine theta. Now, can you guess now? I had to find j. Can you guess what I'm going to do? I got cos theta and I got sine. I need to find j. So can you guess what will be the next step? If you can guess it, I'll be so happy. It's quite easy because it's something like P1, P2 involving a small trigonometry thing, a small trigonometry rule. No one? No one tell me what's the next thing to do. You need to find j. You can see here you have cos theta with j. Here you have sine theta in terms of j. So I don't need sine and cos. I need to find j. So I need to find j. So the next thing you do is pretty straightforward. What is it?
Sine and cos is tan.
No, if you use, that is there, but if you use tan, that's another thing. I want to eliminate sine and cos. I don't want sine or cos or tan. I don't want any of that. How can I remove all of these guys and just get an equation only with j?
You mean remove cos and sine?
Yeah, there is an equation that can remove that. Yes, Dulashika, very good. So we have one answer on the chat. Very good. Children, we use sine square theta plus cos square theta. Can you imagine that? If sine square theta plus cos square theta equals 1, so can you see here? Sine square is going to be the square of this.
Are we doing P3?
So M2, what do you think? In M2, everything else. 5, I mean, this is P2. Sine square plus cos square equals 1 is P2. So 5 over 24j plus 5 over 8 square. Cos square is 5 root 3 over 24j. Again, whole thing square equal 1. So solve this equation, open the bracket, solve this equation, you should get the j value. You will end up getting a quadratic equation, children. You'll end up getting a nice quadratic equation. I think it's better to have the common denominator here. Common denominator it's better. Times 3. So this is 15. 5 root 3 over 24. Whole thing square. I mean, this needs to be squared, children. You really need to work on this. 25 into 3 into j square over 24 square equal 1. Then you'll open this bracket. 5j plus 15 square over 24 square is coming down. 5j when you square it, 25j square, right? How is that? plus 2 times of 5j into 15. 2 times 5j into 15 is how much, children? Because you know when you're opening, this bracket comes twice. Twice of 5j into 15. So twice of 5 is 10, 10 into 15, 150.
150.
Plus 15 square. 15 square is 225, right?
Yeah.
75j square over 24 square equal 1. So I'll multiply the whole thing by 24 square. I'll multiply the whole thing and I'm taking 24 square as common. It goes to the other side. Shall I write 24 square here? Because 24 square is common to everyone, it can go to the other
Okay.
side. Or you imagine you multiply the whole thing with 24 square. So
That's a must.
24 square.
Addition is a you can't take it. It's a must to multiply because addition is a you can't
You
take
can
it.
add, you can directly add. I'm trying to save some steps here. You can go in a longer step. You can directly add these two, Nibuda. The denominators are common. You can directly add these values. And then where it goes, it's over the common denominator 24 square. You can take it to the other side. So just trying to save 1 or 2 steps here. Otherwise, you can write the extra step. There's absolutely no problem. Just trying to save a few seconds here actually. 25j square plus 75j square is 100j square plus 150j plus 225. Children, bring everything to one side, simplify. Can I know what's the answer? 24 square, 225 minus 24 square, how much is it? 225 minus 24 square, how much is it? Namai, how much is it? $225, subtract the 24 square, how much is it?
Minus 351.
Minus 351. Okay, so now it's a quadratic. Take the cal, simplify. ABC. It's a quadratic. 100, 150 minus 351. So you get the first answer of J 1.27. And the other answer negative. So I don't think we need the negative because the
It's a positive.
J, okay, we only need the positive one. So J is have they told us any decimal figures here? Find the value of J. They have not told, right? So we keep to 3SF, then they have not told exact also. Okay, so J. So we'll keep it to 3SF. So what do we get here? 1.268. So 1.29. So J is 1.29 Newton seconds. Okay, Shran, J is 1.29.
Okay, different. Sorry. Answers the clear no nende.
You can write, yeah, you can write, but the other answer is not coming. You need to cut it out anyway, because J is very clearly given. So we have take definitely only the positive answer.
Yeah.
Okay, question number 4. A uniform rod. So weight acts in the center. Uniform rod of length 8A and mass capital M has one end freely hinged to a fixed point A. So it's hinged. So that's important, the word. So hinged means, it's free to move, right? When you have hinged it, it can move freely around the point. It can move down, it can move up, it can move around it. So it's freely hinged to a fixed point A on a vertical wall. One end of a light inextensible string is attached to the rod at point B. So at point B, you have attached a string. So obviously, when you're attaching a string, you need to realize there is a tension here. So I'll just mark it to remember that there is a tension here because it's a string. And even they give me some value here, I'll mark it. And even the weight, mass is M. So mass is M. Let's mark that also because it acts in the center, isn't it? It acts in the center. Okay, so at a distance 4A. I'll mark this as A because this is 3A. It should be A, 4A. Okay. And 5A is the whole thing, remember that. Okay, so then we'll work with this. What do they say? One end of a light inextensible string is attached to the point B where AB equals 5A. Okay. The other end of the string is attached to the wall at C. So we really don't need to bother about that part. Okay, we are interested in the forces acting around the rod. Where AC equals 5A. Okay, so this is the trigonometric part here. AC equals 5A. Yeah, AC equals 5A and C is vertically above A. The rod rests in equilibrium in a vertical plane perpendicular to the wall with angle BAC is 70 as shown in figure 3. Find in terms of M and G the tension in the string. Okay, so how do we find the tension in the string, children? So I think I have marked all the forces. Actually, you need to mark a few other forces here. What are the other forces you have over here? Tension is there, weight is there. What are the other things you have here, children? Talk to me. Is this all? Have I marked all the forces acting on the rod, or do I need to mark another one? Tension, weight, is that all? Yes, unit, very good. So there is another one, isn't it? It's the normal reaction. So are you aware of how to mark the normal reaction at a hinge? So when there is a hinge, at a hinge, it's really important here, children. So in a hinge, there is a little bit of a problem. You guys should know, children, in a hinge, you are free to move. Now, this is not just kept to a wall. Are you guys hearing me? The difference between just now, if you just keep the rod, if you just keep it onto a wall, you can have the normal reaction perpendicular to the wall. That's how you have. But when you hinge it, children, are you hearing me? When you hinge it, there is a problem. When you hinge it, children, the normal reaction doesn't act like in the way you think, but it's perpendicular to the wall. No. Okay, so when it's hinged, when they use this special word, okay, when they use this word only and only if they use the word hinge, you must mark a pair of normal reactions perpendicular to each other, because when it's hinged, children, we are not sure about the direction which the normal reaction acts. So if they tell you that it is hinged, okay, mark normal reaction, mark a pair of perpendicular normal reactions. That means I am marking two. I am marking two components because I don't have the resultant. Perpendicular components. Mark a pair of perpendicular normal components. So that means what I'll mark here is, I'll mark here two normal reactions. I'll mark here. So let me mark here something like normal reaction, say to the x direction, and normal reaction to the y direction. This is how you should mark, children. You really need to mark, you definitely need to mark two normal reactions, because when it's a hinge, when it's a hinge, you really don't know which way the normal reaction is acting. Remember, this is the theory for the hinge. It's the theory for the hinge. So I think you better write it down and kind of, make it a big thing there. Okay, so whenever they use the word hinge, you need to immediately mark two normal reactions perpendicular to each other. Got it? Got it? Okay, so Rx, Ry marked a pair of perpendicular normal reactions. Okay, so now I think I have marked all the forces. My task is to find the tension. How do I find the tension? How do I find the tension? Talk to me. How do I find the tension? I need to find this tension. How do I find it? So what we do is, obviously, children, it's in equilibrium. So there are three things to do: up equal down, left equal right, and moment. So out of all those options, I think I can see T is unknown here. R is Ry, Rx are also unknown. The best thing to do here is to take the tension. I will take moments around. I will take moments around what? Which place is the best?
A.
A, exactly. Because if I take around A, both of these guys don't come. Both of these guys don't come if I take moments around A. Okay. So let's take moments around A. Children, I think if you're taking moments around A, again, you need to think about these forces. You have to resolve them. So let's resolve them. So let me make it a little bit bigger. So let's work on this. So this tension needs to be resolved. Children, how do you get the resolve this? Now you can see here, AB and AC is 5A, which means this is about triangle, which means this is an isosceles triangle. Can you guys see? AB, AC are equal. It's an isosceles triangle. In an isosceles triangle, angles at the base are equal. Can I have this base angle? These two are the base angles. How much is the base angle? 180. Subtract from 70 and divide by 2. How much is it?
55, right?
55. 55. And then let's mark this. Okay, so 55. I need to actually 55, and then this guy is also 55, right? This guy is also 55. What about this angle? Mark the T on top here. What about this angle? Can you guys tell me what's the value of this angle? Okay, what's this angle? Because I want the I want the vertical. How much is this angle? The one that I'm touching now. How much is this? Talk to me. Yeah, I have the units answer.
That one is also 55, right?
Why is it 55?
Alternate angle.
Alternate angles. Can you see? It's 55 because of alternate angle. This 55 comes from here. Alternate. So actually what I need is this 55 here. I don't need this guy. Shall I erase this? I don't need, because it will just create a mess. I erase this because I need to resolve here. So now you can see I can resolve up and down. So this guy upwards I get T cos 55. And this way I get T sin 55. Can you guys see? Because I need those two guys. I need those two guys. Now, children, let's take moments. So taking moments here is a tricky business. So let's take moments. So what do you get when you take moments here? Moments around the point A. So when you take moments around the point A, what happens? So the first guy. So keep your finger around A. And then what happens? mg gives a clockwise moment or anti-clockwise moment? Children, mg gives a clockwise moment or
Anti-clockwise.
Anti-clockwise. Mg gives, so you can see mg gives anti-clockwise. So I'll put minus mg. And what's the perpendicular distance between mg and the point A? Can you guys see? So the mg is this force. See, I'll mark it like this. Mg is this force. So I need the perpendicular distance between mg and the point A. Between this line and this. What's the perpendicular distance between this line and this? Do you see it? It's this distance, right? Do you see the perpendicular distance is this distance? Make a the perpendicular distance. Isn't it this distance? The perpendicular distance. So how do we find that? What do we know here? I know here this distance, this short distance is 4A, right? Why? It's at the center, mg acts at the center, right? Mg is the weight. It acts at the center. Whole rod is 8A, so the middle is 4A. You know, how much is this distance? You can take this small angle here. That is 70,
20.
80, 90, 20. So
4A cos
4A
20.
cos 20. 4A cos 20. 4A cos 20. Can you guys see this? So these are really important, like very tricky stuff. Then the next one, tension. With the tension, there are two components. Tension, there are two components. So you have to, if you resolve tension, you will have to use both the components. Otherwise, if you keep the otherwise, I don't know, you can even keep this tension and get the perpendicular distance also. Do you prefer that, or do you prefer to work with two tensions? Or do you want to get the perpendicular distance directly to the force? Shall I just use the resolve one? What do you prefer? What do you prefer?
We'll do the resolved one.
We'll do the resolve one. You mean with T cos 55 and T sin 55, right?
Yeah.
Yeah. Okay, so then let's work with T sin 55 now. Guys, work with T sin 55. So T sin 55 is like this. So is it giving a clockwise moment or anti-clockwise moment around it? Keep your finger around A. Okay. And then see whether it gives a clockwise or anti-clockwise moment. So keep this around A. Okay, and you have this like this way. And this is pulling which way? It's pulling this way, right? So you are moving in
Clockwise.
Clockwise. So plus T sin 55. But what's the perpendicular distance between this line? Between point A and this yellow color kind of line. What's the perpendicular distance? Can you guys get the perpendicular distance? Shall I erase all these? What's the perpendicular distance? Can you guys see it? From point A to this dotted yellow color line. What is it? Do you see it, this distance?
4 cos 70.
Not 4, not 4.
4A.
Not 4A. Look at this. This
Ah, no,
whole
5A, right?
5A.
5,
Children, you need to
5A
look at
cos
this. It's
70.
5A cos 70. 5A cos 70 is this distance. Can you guys see it? This AB distance is 5A. 5A cos 70. There another line. So it's 5A cos 70. And then one more guy, T cos 55. So T cos 55, does it give a clockwise moment or anti-clockwise moment? So keeping it on this axis and then you're pulling it upwards, right? Pulling it up,
Clockwise.
it's giving again clockwise. So it's giving a clockwise moment. So again, it's a plus. All right, here plus T cos 55, children. So pay attention. I'll again mark this with the color. So T cos 55 is going along this line of action. So what is the perpendicular distance between the green color line and A? What is the perpendicular distance between the green color line and A? Do you guys see it? The green color line and this point A. What's the perpendicular distance? Green line and point A. What's the perpendicular distance? Children, talk with me. Do you see AB distance is 5A?
Yeah, 5A cos 20.
5A. Okay, remember it's 5A cos 20. Exactly, right? So this distance is 5A cos 20. Do you guys see it? This distance is 5A. So maybe this is 5A cos 20. So this is going to be T cos 55 into 5A cos 20. So taking moments is quite tricky, isn't it? Taking moments is quite tricky. This requires a lot of practice. I think you guys really need to look at this again. Take time after this is over and again go through it and try to do it alone because you just look what I did. So I think better you do it again. And now what? Make T the subject. Your T comes in terms of M. Your T comes in terms of M. Get it? So minus mg, I'll take it to the other side. So T sine 55 into 5A cos 70. And then plus T cos 55 into 5A cos 20 equals mg into 4A cos 20. So they have told to give you an answer in terms of capital M and G. Don't use G as 9.8. Don't use G as 9.8. I'm cancelling off the A. Take T out. So when T comes out, you get 5 times sine 55 times cos 70 plus cos 55 into 5 times. There's a 5 times there also. 5 times cos 55 times cos 20 equals mg into 4 cos 20. Don't touch the G. So tension equals mg into 4 cos 20 over 5 sine 55 cos 70 plus 5 cos 55 cos 20. Can you guys type this thing in the cal? Don't give the G value. Answer should come in terms of G. So then give the decimal here. How much is it? I think if we had resolved this distance, it would have been a lot easier. You know, what we did was a very long method. Just taking this distance along the isosceles triangle would have been quite easy, children. Without resolving T, we could have done in a very short way. Okay, anyway, it's fine. So what's the answer? This was a time-consuming method, to be honest. 4 cos 20 over 5 sine 55 cos 70 plus 5 cos 55 into cos 20. What do you get? Did I do something wrong? Where's the minus? It's in radians. Sorry, this should be in degrees. Shift mode, it should be in degree mode. Make sure the cal is in the correct mode. Okay, so now give it. Okay, 4 cos 20, 5 sine 55 cos 70, 5 cos 55 cos 20, and I get 0.91, 0.9177, which means 0.918 mg.
Yeah.
0.918 mg. That's what they want. Okay. This was actually the long way. I think, children, one of the easiest ways to do this sum would have been to actually not to resolve. not to resolve the t, but rather directly keep the t as it is and resolve the distance. This 5-way, you could resolve and get the perpendicular distance, and that is so easy. Then only one tension comes in, tension into perpendicular distance, and then you would have only gotten mg into 4a cos 20 and tension into this perpendicular distance. That is quite easy, children. You don't need to go into this much of simplification. Okay, anyway, so I'll go to the next part. Okay, I hope you guys are done. Part B, the magnitude of the force acting on the rod at A. So they are telling the force acting on the rod at A. So I told you what's the force acting at A. At A, you have a hinge here. So, isn't it? So I told at the hinge you have two normal reactions, Rx and Ry. The magnitude of the force acting on the rod at A is lambda mg, where lambda is a constant. Find a 2s at the value of lambda, 6 marks. So how do we do it today? How do you get the value of, so they have told you the resultant force. The resultant force at A. How do you get the resultant at A? How do you get the resultant force at A? What should you do? You know the force acting on A has a x component, Rx and Ry. How do you get the resultant of these two guys? How do you get the resultant of two such forces? You have to
Square
square and
square.
square root Rx square Ry square. So this is the resultant is equal to lambda mg. So all you have to do is here, children, get what do you call? Get Rx and Ry. So Rx you can do vertical equilibrium. So let's do horizontal equilibrium. So horizontal equilibrium, what comes for Rx? Shall I make it smaller? So what comes for Rx? You can see here, children, because I have resolved in this manner, it's very easy for us now. So what's in the horizontal direction? You can see t sine 55, isn't it? Children, t sine 55, is this okay? T sine 55 is equal to Rx. Do you agree? T sine 55 is to the right, Rx is to the left. These are the only two horizontal forces. There are no other horizontal forces. Do you agree? Children, do you agree?
Yeah.
Then take the vertical forces. Why? Upwards. So upwards, what do I have? Upwards, I have T cos 55. T cos 55 plus I have the Ry. Plus I have the Ry. Are you guys with me? Okay, T cos 55 plus the Ry. Talk to me. What else?
And the weight.
Minus mg. So equal mg. Equals mg. You get Ry also. When you make Ry the subject, you get mg minus T cos 55, children. Okay, so now it's time to put it to this equation. So find 2SF. Okay, I think we should have taken a little bit more SF here. So I hope is it there in our calculators, because the tension value should be put 0.91772. Okay, so we'll use the higher significance. Okay, so then let's get the resultant. So lambda mg equals Rx square plus Ry square root. So what happens? I think I can, is it okay if I do like this? Squaring. So if I square both sides, you can see I remove the root here, right? Do you guys see it? Dala, can you all understand what I'm doing? Rx square plus Ry square, you square both the sides, so that this big root removes. Okay, these things are easy, just M1 stuff. Left equal right, up equal down. You need to talk with me. So you get here lambda square, here you get m square, g square, everyone gets squared. Rx square is t sine 55 square. Ry square is mg minus t cos 55 square. So I don't think, children, you need to suffer. We'll use the cal here. T is 0.9177 mg into sine 55 square plus here mg minus t is 0.9177 mg cos 55. Children, do you agree? I know the simplification is a little bit tough here, but do you see what I did here? I replaced the t. I replaced the t with 0.9177 mg.
Yeah.
Can you see? Okay, and then I think it will give the work to our cal. Let's not suffer. So lambda square, m square, g square. Let's give the work to our cal. 0.9177 into sine 55. Give the work to the cal. 0.9177 into sine 55. So this is the answer. 0.9177 into sine 55, and that answer should be what, Puda? It should be squared. Can you see? So 0.5651. And m square, g square. I hope you guys are here understanding this. Are you? Children, talk with me. Did that go into your head? You guys need to, kind of give me a feedback. This should be okay. Just type it in your cal. And what about this guy? Now don't go to open the bracket like quadrant. I mean like a factor opening brackets. That's going to be a headache. So this is simply 1 mg, right? Here there is no value, means it's 1 mg. So subtract these two guys, 1 mg minus 0.9177 cos 55 mg. So these are like terms. You can subtract and get the value here. So how much is it? Can you look at this, children? 1 mg, you can't type mg. So 1 minus, look at this very carefully, 0.9177 into cos 55. Do you see it? Do you see what I did here? 1 minus, I subtracted. 1 minus 0.9177 cos 55, because these are like terms. Both are having mg. So it's like 1a minus this 0.9177 cos 55a. 1a minus this many a. So subtract them and square it. Subtract it and get the answer, and then you have to square it. Square it. Do you see? So 0.2243. So 0.2243, and don't forget mg.
M squared G square.
G square. So m square g square is common to everyone then. Can be removed. And then final touches, lambda square. Whole thing add and root it. 0.5651 plus 0.2243. Give it to 2 SF. They want 2 SF. 0.5651, 0.2243. So that gives me the value 0.888. So 2SF
0.89.
So 2SF answer is 0.89. Okay. Okay. So question number 6. Two particles A and B of mass 2 kg and 3 kg respectively are connected by a light inextensible string. The particle A is held at rest at the point X. So let me make it a little bit bigger. Okay. So particle A is held at rest at the point X on a fixed rough ramp. So there's a rough surface here that is inclined at an angle theta to the horizontal, where tan theta is 5/12. The string passes over a smooth pulley P that is fixed at the top of the ramp. Particle B hangs vertically below P, 2 meters above the ground, as shown in figure 4. The particles are released from rest with the string taut so that A moves up the ramp, and the section of the string from A to P is parallel to a line of greater slope of the ramp. The coefficient of friction between A and the ramp is 3/8. So mu is 3/8. Air resistance is ignored. Find the potential energy lost by the system as A moves 2 meters up the ramp. So when A moves 2 meters up the ramp, what happens to B? A moves 2 meters up the ramp and B moves 2 meters directly down, isn't it? You guys are with me? So A moves 2 meters up the ramp. B moves 2 meters directly down. Here. So B is down here, A is up over here. So let's calculate what do you mean by find the potential energy loss? Because you can see now A is actually moving up. So when A is moving up, you have a, but when you are going up, we have a gain in potential energy. So A is gaining in GP, but object B is moving down. So object B is losing its GP. So end of the day, I think more than the gain, the losing amount is higher, because you can see this guy is directly moving 2 meters down, while this guy is not directly moving 2 meters up. It's moving a slant distance. So the direct distance is lower than that, right? Are you guys with me? Direct distance is this guy, the H. How much is the H? So tan theta is given. So in this situation, you will have to find the cos theta and the sin theta. So tan theta is 5 over 12. Children, how much is cosine sine? Tan theta over opposite over adjacent. How much is the hypotenuse? Using Pythagoras, tan theta opposite over adjacent. Pythagoras theorem, the other side is 13, right?
Yeah.
Means cos theta is adjacent over hypotenuse, so 12 over 13. And sine theta is opposite over hypotenuse, 5 over 13. Is that correct? Okay, right? So you need to fix that. You have to find that. That's the first thing to do. Okay, so let's find the GPE gained by A. Part A. GPE gain by A. So equals MGH. Always GP is MGH. So M is mass of A is 2 kilogram. G is 9.8. Okay, what's the height? What's the perpendicular, the height that A has climbed? Can you guys tell me? So we can't take the 2 meter. 2 meter is along the plane. So you have to take the perpendicular distance that A moves. What's that distance? What is the perpendicular distance that A moves shown up the plane? Come on, talk to me. So this is theta. You guys can see this is theta here, isn't it? This is theta. So can't you resolve 2? H equals to
2 sine
2 sine
theta.
theta. H equals to 2 sine theta. 2 sine theta. So H equals 2 sine theta. So let's put the values. 2 into G is 9.8 into 2 into sine theta is 5 over 13. Get the whole value. So GP again, how much? 2 into, I want answers fast and you guys are taking a little bit long time. Answers quickly. How much is it? Are they? Please confirm. Please confirm. You guys need to be fast and confirm me the answers. And then GPE lost by particle B. Is this correct, children? Please confirm. The chat is there and you can talk to me. Please don't copy paste the answers. MG
Answer is correct.
Answer is correct. So GP lost by B, mass is 3 kilogram. G is 9.8. Height is direct because B is directly moving 2 meters down. Per direct height is 2. So how much is it? 3 into 9.8 into 2. So you get there 58.8, right? Or you get 294
Yeah.
over 5. So they
Yeah.
want, I think you can see this is larger than this value. More than 196 over 13. This guy is larger. That's why they want the loss. So potential energy loss. Lost by the system. Potential energy lost by the system. So the potential energy lost by the system is 294 over 5. You subtract the 196 by over 30. Okay, because this is the gain, this is the loss. The loss is bigger than the gain. Subtract and just get the value difference. How much is it? 294 over 5, subtract 196 over 13. That gives some 2842. Do they ask in terms of, right? 2842 over 65. The decimal answer is 43.7. So I think we will definitely be using this answer for the next step. So I will be using the decimal, the exact answer. Okay. So when I go to the next stage, I will be using the exact, but I wrote the decimal answer for part A. So this should be the answer for part A. Okay, children.
Yeah.
Then let's go to part B. Part B. Find the work done against friction as A moves 2 meters up the ramp. So work done against friction is what? Work done against friction equals, what's the rule? Work done against friction equals friction into distance, right? Force. Work done is force into distance. So here the force is friction and the distance you move should be D. I just marked it as D. So what's the friction here, Buddha? So how do you calculate the friction? You know, you are moving up. You know, there's a normal reaction. So, you know, friction equals mu r, right? You guys know friction equals mu r. So, what's friction? So, mu is 3/8. Today, what's the normal reaction? Normal reaction equals to, can you guys tell me what's the value here? Mg, this is M1. You have to resolve your weight, right?
Yeah.
So, what do you get here? Normal reaction equals.
So that's up equal down. Yeah.
Yeah. So, 2g.
2g. That's theta.
Theta.
2g cos theta. Normal
So
reaction is 2g cos theta.
r is 2g cos theta.
So put the value 3/8 into 2 into g into cos theta 12/13. How much is it? Friction. So put that value for friction. 3/8. How much is it? 9.8 into 12/13. 441/65. Is that okay?
Yes.
Check
Yes.
my figures. 441/65 into distance is how much? Children, what's the distance A moves under friction? How much of a distance does A move under friction? So it moves how much? Does it move perpendicular? Do we use the 2 sine theta now? So A is moving along the plane to a distance of how much? Under the friction force, it travels a distance of 2 meters in the plane. So it has to be 2 Buddha, not any other perpendicular distance, because you are directly moving a distance 2 meters along on this plane with the against friction. So multiply 441/65 multiplied by 2, you get work done is 882/65, which so that is the amount of work done. Joules, give that also decimal, so 13.6. So keep the exact with you always. The exact is needed. We will be needing the exact for the next part. So when I'm going to the below parts, and if I want to get this work done figure, I will be using the full figure, not the decimal figure. Okay, so keep the full figure and the decimal both in hand. Okay. Then the next one. When B hits the ground, B is brought to rest by the impact and does not rebound, and A continues to move up the ramp. So pretty much M1 story, right? You remember in M1 also you have this guy hits the ground, the other guy continues to move up. Okay, and when B hits the ground, B is brought to rest by the impact and does not rebound, and A continues to move up the ramp. Use the work energy principle to find the speed of B at the instant before it hits the ground. So they want you to use the work energy principle to find the speed with which B hits the ground. Okay, so they want you to find the they want you to use the work energy principle to find the speed at which B hits the ground. Okay, so how do we do that? How do we use the work energy principle? Do you remember the work energy principle? First, let's write the work energy principle. What's the work energy principle? Children, what's the work energy principle? Work energy principle is what? Work done against friction equals to work done against friction equals to what? Change in energy, right? Have you guys heard of this? Work done against friction equals to change in energy. Change in energy means the initial energy you had minus the final energy that you had. Initial energy minus final. So this is the work energy principle. But are you guys with me? So work done against friction we found. What's the work done against friction? We found in part B. Work done against friction is 882/65. Is that okay? Okay, so what's the initial energy you have? So initial energy you have is, now you can see you start first, you have A and you have B. Okay, so you can see at the beginning, A and B are both starting from rest, right? Are you guys with me? A and B are both starting from rest. Okay, and then A is moving 2 meters. I mean, A is having a gain in potential energy. I think it's better you consider for each object, like, think about each object. Okay, so if you think of each object, if you think of particle A, so particle A initially, it does not have any kinetic energy. It has, it starts from rest and then it's moving up. And then what it has is it has a gain in GPE and it has a gain in kinetic energy. Do you see? So when A is moving up, its GPE increases, and A has a what do you call? And A has a kinetic energy. Okay, so that's the final. Okay, how do I say this properly? Okay, initial minus final. Okay, so initial minus final. I think we need to use the GPE, that the values that we found. Okay, so A is moving up, B is moving down. So you know when that happens, there is a loss in GPE. Okay, so you have a loss in GPE. So initial minus final. So when you subtract the initial and the final energy, you know from the initial to final, you have a GPE loss. Do you agree with me? Children, do you agree? Starting from initial, and when you start with final, initial is the place where you start. Final is the place where you went. So from starting to end, that is from A coming from here to here and B coming from here to here, you understand that you have a GPE loss, isn't it? Children, do you agree with me? A moves from this position to this position. B moves from this position to this position. So during that process, you understand that you have a GPE loss, right? So the change in energy gives you a loss in GPE. Agree? The change in energy gives you a loss in GPE. Is that okay? Harder? The GPE, if you consider GPE is a loss. So let's consider the change in kinetic energy. So I'm taking the change in energy. I'm considering the change in GPE and the change in KE. Okay, so change in energy means I am taking the change in the GPE and the change in the KE. So change in GPE is a GPE loss, which we have already found in part A. Okay, what about the change in kinetic energy? Let's talk about the change in kinetic energy. So initially, do we have any kinetic energy, but with any particle? Initially, does any of our particles have
No.
kinetic energy? No. So
No.
initial minus final. So minus final. What about the final kinetic energy? So you know at the final stage, both of them reach a certain velocity, and both the velocities are equal, right? Because they are both traveling on the same string. So the velocities are equal. Initial kinetic energy of both the particles are 0. Final kinetic energy of the particles, both of them reach a velocity v. So initial minus final kinetic energy. Final kinetic energy is half. A is 2 kilogram into V square. Okay, so plus actually when the plus can be then minus again, so that is also a minus. Then half mass is 3 into V square. I'm sorry for writing inside the lines. So I should have kept a little bit more space. Shall I explain it again? Better I explain it again, right? And write it in a place where we have space. So let me explain it again. Part B, part C, right? Work energy principle. So work energy principle is, children, work done by friction. Work done by friction equals change in energy. So now stay with me because I know this is something that is really hard for many children to understand. Work done by friction we have found. Work done against friction 882 over 65. So pay attention to this. That is okay. Normally, children, change in energy means what? Change in energy means the initial minus final. That's the meaning of change in energy. So initial minus final. That's what we mean. So when I'm working here, children, I'm going to consider two types of energy. I have GPE and KE. So this 882 over 65 refers to the change in GPE plus the change in KE. So actually here, a change in energy means the change in GPE plus the change in KE. Can you guys understand? So what's the change in GPE? Change in gravitational potential energy is initial minus final. Now I think you can see here in part A, we have accounted that. Can you see? Starting from beginning to end, we got the GPE. We got the GPE gain by A, we got the GPE loss by B entirely. So when you move 2 meters, when the system moves 2 meters, the system experiences GPE loss. So end of the day, initial minus final, it's a minus answer. You get a loss here. So GPE loss. Okay, are you guys with me? Okay, are you guys with me? So then I end up getting here. So I end up getting here a GPE loss. So final minus initial minus final. Initial minus final for GPE. So that gives me a GPE loss. Okay. So GPE loss, which we found out, GPE loss figure we found out, plus the change in K. Change in K is what, sure? Change in K is also once again, what do you mean? Change in KE is once again initial KE minus final KE. So initial KE minus final KE. So final KE, how much is it? So initial KE, you know, the whole thing is 0. Final K is, children, half mv square. Both the particles are reaching a velocity of v. Both the particles are reaching a velocity of v. Half into particle A is 2 kilogram into v square minus half into 3 kilogram into v square. Is that okay? 882 over 65 equals GPE loss. GPE loss is how much, children? You calculate GPE loss is this value, 2842 over 65. It's a loss, so it's negative. So GPE loss 2842 over 65. Is this okay, children? Can you guys work with me? Okay. So let's get the figures here now. We have to make V the subject. Let's make V the subject. Sorry, wait. GPE loss, you have to put the figure you got here. GPE loss 2842 over 65. Yes. Okay, you put the figure you got here. Okay, so then what do you get here, children?
So what is it? It's a minus then.
Minus.
The GP loss.
Yeah.
You don't put minus, only the value.
Yeah, only the value. Yes.
Because it says GP.
Yes.
Okay.
Yes. Then let's get the answer. 882 over 65. I think it's equal to 2842 over 65. So minus v square minus half into the 2 is 1.5 v square, right? So let's take everything to one side. 1 minus 1 v square minus 1.5 v square minus 2.5. I'll bring it here. Plus 2.5 v square equals 2842 over 65 minus 882 over 65. So what is it you get here, children? So you need to type the whole thing and divide it by 2.5. What is it? Two 2842 over 65 minus
784 over 65.
Yeah, this whole thing divided by 2.5. 784 divided by 65. And then V is the square root of that. So take the square root of that. Square root answer, which is 3.47 3SF.
Yeah.
3.47 meters per second. So this is the speed of B at the instant before it hits the ground. Okay. Okay, so moving on to the last part. Particle A comes to instantaneous rest at the point Y on the ramp where xy is d plus 2 plus d meters. Use the work energy principle to find the value of d. Okay, just took the figure here because we really need to look at the figure and we can't keep on turning the page. Okay, so I just took the figure here so it's easier for us to look at it. Now what do they say? So actually in the earlier case, I used 2 meters coming here, but I think 2 meters was before. So this was traveling 2 meters up the plane. And now what are they saying? So they say particle A comes to instantaneous rest at the point Y on the ramp. Now you know when particle B hits the ground, okay, we found the speed that particle B, which it hits the ground. And then you know that's the exact same speed that particle A has over here. Both of them have the same speed, but you know, even though it hits the ground, now B stops, but A doesn't stop. A will continue to move up. Do you guys agree? A continues to move up. So they are saying particle A comes to instantaneous rest at the point Y on the ramp where xy equals 2 plus d. So I hope you guys can see that this small distance is what they consider as the d here. So xy, so 2 plus d. Okay. So use the work energy principle to find the value of d. So you only need to consider this small part here, children. You only need to consider this small part here. So how do we use the work energy principle? So how do you use the work energy principle? Again, in part D, work done by friction equals to change in energy. Change in energy. So consider that small portion. So consider the small portion. I'm going to make it a little bit large so that you can see it easily. So I'm going to take that small portion here, children, this small portion. Again, I'm going to apply the work energy principle to this small portion. So work done by friction. We found the friction force. Can I have the value of the friction force that we found earlier? Friction force doesn't change. What's the friction force? Can you guys quickly tell? Friction force, we found it to be how much? 441 over 65. Friction force is 441 over 65. And the distance you move with the friction force is this distance d. Okay, so change in energy is, children, what? Change in energy is initial minus
GPE.
final. So initial energy minus final. So what's the initial energy you have here? Initially, you can see you have kinetic energy. Isn't it? You have a velocity. So you have a KE gain. So you are, sorry, KE is lost. Because why? You have initial kinetic energy which becomes 0 here. At Y, you are at rest. So that means KE is totally lost. Right? So initial kinetic energy minus final kinetic energy is a KE loss, which is positive. KE loss is positive because initially you have a high kinetic energy and at the end it's gone. And then what about GPE? What about GPE? You are going up, which means you have a GPE gain, right? So GPE gain. So at the beginning, we will consider there is no GPE. So we will consider this as the 0 level. At the beginning, there is no GPE. At the end, there is GPE, right? So change in energy. Okay, so let's at the beginning there is no GPE. At the end, there is GPE. So this is minus GPE gain. So minus GPE gain. I don't know whether you guys can see that. Kinetic energy loss is positive because at the beginning you don't have K, you have K, and at the end it's becoming 0. So initial minus final, when you do initial minus final, initial there is K, final there is no K, so it's a KE loss is positive. And then GPE, at the beginning you consider GPE 0 and you are moving up. So beginning minus final, final you have GPE. Okay, so final one is negative. Okay, so 441 over D into 65 equals KE loss. KE loss is half mass is 2 into V square. Okay, half mv square, which we found. V value also we found. Can I have the V square value? V square value we got, right? 784 over 65. Minus GPE gain. GPE gain is mgh. M is 2, G is 9.8, H is the small distance is, children, D sine theta. I hope you guys can see that. And now it's a matter of making D the subject. Okay, we just have 2 more minutes. Sine theta was how much? Sine theta is 5 over 13. Let's quickly finish it. 441 over 65D plus 2 into 9.8 into 5 over 13 D equal half into 2 into 784 over 65. How much is the answer? Can you guys quickly tell it to me? We have, how much is it? 441 over 65 plus 2 into 9.8 plus 2 into 9.8 into 5 over 13, which gives you 931 over 65D.
Yeah, and the other one is 784 because 2.5 cancels.
784 over 65.
Yeah, and the final answer, children. 65 cancels off. So you get 784 divided by 931, right? 16 over 19. Is that correct?
16 or 19.
16 over 19.
16 over 19.
Okay, so this is really important. This minus sign GB, beginning initial 0, final is initial minus final. Minus we have gone up, so it's a gain, so it's a negative. Okay, children. So then I hope you understood this. Okay. Okay, then.